Hey everybody, it is the start of office hours. Got the camera fixed up a little bit more. It doesn't look as crazy today. Let's see here. Maybe we'll do some My Pearson to start. I think so we've had any 320 or 201 here. Never know. I feel like the lights need to be brighter now. Let me look at the lights right here. Is that my phone? I don't know how to do anything. This is never make changes live on air. Oh, no. Oh, I need to go to this button now. There we go. I'll fix it later. Looks all right. Let's see right here. Let's go over to My Pearson. If you're here, you get to choose what we do. So let me know if you have any questions. It's just going to fly everywhere. Let's see. Chapter 2 homework. That is coming up. We did Chapter 2 homework previously. So there is a video on that. Can we start visualization 4? Of course. Let's do it. You're here. You get to decide. Let's do that. You come to office hours, you say, hey, Brian, let's do this. And you got it. When there's a bunch of people, we vote. When there's a few people, you say, let's do this. And we do it. Let's go over right here. I'm going to sit up straight. Let me go back. I was adjusting the lights. Does it show me my light setting? Huh. So that's got it. Great job, Kayla. Good to see you, Kayla and Sarah. Let's hop over here. It's 20 Point Tuesdays. Let's give some 20 points out. Make sure the button works. It's not Mega Mondays. It's 20 Point Tuesdays. Should turn off. I need to fix the buttons on this screen. There we go. I've got so many buttons. I'll show you guys all my buttons. There we go. Okay. Let's see. So you can see, here's an inside. We start off, we have a little fun. Here's an inside peek inside my room. So this, whenever you're seeing me click around on stuff, these are all the buttons I have. Like, here's the Monday, Tuesday, Wednesday, Thursday daily events. Here's my rain and thunder and all that stuff to make rain and thunder appear. So all these different buttons, boss battles, the new effects tab right here that has like it's my favorite song right here. And I feel like I made myself too tiny in this corner. Where's my camera? We're gonna fix this. Then we're gonna get serious here with the visualization assignment. There we go. It's too small. All these different fixes. We've got Tiny Brian right there. So you can see Tiny Brian's icon right there. It's Tiny Rick. So there we go. All these can't put on the 80s effect. I can put on the 80s effect. There we go. So let's head back right here. Let's start some visualization. Let's take the zoom off. Let's go back. Let's peek behind the curtain right there. See what's going on. But right now what's going on is visualization number 4. Let's do this. This music just gets me hyped. Visualization number. This is when you complete this visualization, you'll be halfway done with the visualizations for this class. Halfway done with visualizations. My gosh. I gotta look at the numbers on these on YouTube, make sure they're the right ones. Okay, let's turn on the music a little bit and get serious. Okay. You are the intern to write this speech for a local politician. Wow, we changed it this semester. The politician wants to talk briefly about UT students. Good to see Calzone Tyrone. Good to see you. First stream here for the semester. We got music. We got new stuff this semester. We got effects. So good to see you here, Calzone. We're always growing what we're doing. Calzone, fan favorite. I need to not hit every effect at once. Let's do this. Thank you so much, Calzone. I reset MuBot this semester since it now tells students how many extra credit points they have in the class. And we are going to now be a speechwriter for a politician. Dataset context. Answers of UT students from a survey of various types of questions. Use the file Stat201 survey data to create the following pivot charts. See below for the details required about these. So we're going to have to make 2 pivot charts. 2 pivot charts. Okay, let's do this. You ready? We're going to download 2 seconds because I might have data open I can't show in Excel. Let me see. It's just survey data, it looks like. Well, let's close it out anyways. Okay. How's everyone doing? How are you doing, Calzone? So good to see you. Calzone came to our first Kahoot and has been a fan favorite and has watched 5 hours of just swinging by in the last since we started tracking this since last semester. Calzone, I don't mean this bad for my students. You've watched more time of this class than some students have, and I really appreciate that. Calzone's just fan favorite. He is literally a legend in the class. And you know what? Because of that, we're going to fix his points. Every semester, Calzone swings by. We're fixing his points. 2 seconds. Come bring up MuBot here. Let's go to the currency. And let's fix Calzone's points, because that is something that should not exist. Edit. Calzone, if you ever want to check your points again, you're back to where you should be. I haven't edited many people's points this semester, but I can't let it stand for Calzone's points to be at a level they should not be. Okay, we're back now. Okay, it's time to get serious here. This is where I'll probably put the spot in the video where we're talking about pivot charts and pivot tables. So with this right here, this is an Excel spreadsheet. I think we've all seen these before, Excel spreadsheets. We've got here rows, which are individuals. This stands for person number 3, even though it's in row number 4. This is the third individual who was a male, 20 years old. They were born in Tennessee, I believe that says, born in TN. You can do that, expand the columns. You can read the questions. You don't have to do this. It just, if you really want to see what the questions say, they're pretty self-explanatory, like your distance from campus, your high school GPA, Greek life, family order, broken a bone. Do you know what a Roth IRA is? So with this first number here is the identifier. We're not going to analyze the identifier, and you do not have to do this. I'm just letting you see what the variables are. Here's what you do. You click in one spot. Click one spot in the data table, and on a Mac or a PC, hit Control or Command-A. So Sarah, make sure you have the dataset downloaded, and on a Mac or a PC, hit Control on a Mac PC or Command on a Mac, Control or Command-A. Okay, that's step 1. Control or Command-A, we're good there. So now we've hit Control or Command-A, we're going to go to Insert, and then we're going to go to Pivot Table. So you select all the data. Sometimes if it's a different sort of data set, you might have to like select it. Like I was working with someone else and their data was a bit weird. So I was like, okay, we're going to have to like select it, click the top cell, and then click the bottom cell. But this data is properly cleaned and organized. So you can just hit Control or Command-A, selects all the data. We're going to go to Pivot Table under Insert. And now it's actually set up. Let me zoom in on this. It's actually set up properly right now. We're going to put it in a new worksheet. We've already selected the data. So there's many steps to do this if you do it a different way. This is my favorite and quickest way to do it. So we're going to go ahead and click OK right here. And Sarah, amazing job on all the points, because we're just going to keep putting higher and higher tiers. So I'm just going to, I want to see how many points people get and how many hours people get this semester. So I might have to disappear. Good thing I can just like disappear when I need to. So with this, and I think I can make it bigger. I can't. The right side screen is going to, yes, Calzone might have cheated and got there already. We're going to have tiers even above that probably. We're just going to keep making new tiers like we said yesterday. And then we're going to have a big bonus for the person who gets there. So it might be someone else might, I don't know, for your class, you might be the one. So let's see. So what is the first graphic we need to make? The first graphic we need to make is going to be, I know, Lucy, it's awesome. I love it. I love seeing how many. Display average weekly hours worked that shows the difference between gender. Okay, so we have a 3 variable display right here. Good job, Lucy. And Lucy, you're doing excellent too. I love positivity. So we have 3 variables. So whenever you make, here's a big note to have. Whenever you make a pivot table or pivot chart, the first thing you need to do is choose what variable do you want to display. So I'm choosing my variable I want to display. You're welcome, Lucy. I'm going to choose this variable. I'm doing slightly different stuff than you're doing, but when you choose the variable you want to display, you want to go down and put it in the values. I'm trying to think if I could zoom in really easily on this. You know what I need to do? 2 seconds here, everybody. I'm going to make it so you can see it a lot better, but I have to like change how the scene works. That's HackerMan logo. 2 seconds, because this will help when I do this in class too. Screen view. Okay, I think that's it. Okay, here's the large view. Okay, let me do this. Let me copy this. Never do anything live like this. That's like the key of... Okay, 2 seconds. I'm going to make a mistake and mess something up. So since we are doing Q20, do we drag it to the values? Yep. That's correct, Sarah. That is correct. Whatever you are displaying will be dragged to the values. And there. Okay, so that should be that zoom in. I should just not do this. Okay. You're seeing, once again, super behind the curtain right now. Okay. I'm making it so you can see it, and this will probably help when... Okay, because it's pretty important to know how to use these. You know what I could do? I could maybe... I'll have to remember this. I'll totally forget why I made this later on. Like when I'm looking at this later semesters, I'll be, what the heck was the point of this? So let's see if this, you can tell me if this helps right here. So it's like a zoom in of what I'm doing. We'll make it big like this. Okay. So here's like a clearer view of this. And I think, we don't need this bottom thing right here. That helps good. Yeah. And I'm going to use this when I teach this during the lecture time. Because it's just something so small, it's hard to see. Okay. So that's like a zoom in of like what's going on the side. Okay. So, because these columns are super important, like what you put in each one is super important. So now whatever I do over there, you can see it like a zoom in of what I'm doing here. So I'll try to put the variable that I'm using on the screen. Like we're going to use high school GPA right here. So you can see high school GPA. And the most important thing you're going to do is put it into the values. So with the values, this is the variable you are displaying right here. So we're just going to drop it into values, and now you can see over here, and I can make this bigger easy. Like that's easy to make big. So we are displaying right now the sum of high school GPA. On a Mac, you will see an eyeball right here. So on a Mac, there'll be an eyeball. On a PC, it'll be a drop-down menu, and you'll go to the value field setting. The value field setting. So with the value field setting, I can make that easy to see. That's an easy one because it's in the center of the screen. So with the value field setting, this is how you're displaying that value in the field. And I think we're doing average, so I'm going to pick average also. So we have it right here. We're going to click average. We're going to zoom back out so you can see. And we'll bring back up. You can now see that that is the average high school GPA. Now pause right here. I think it wants us to display, how many decimals does it want? Let's take a look. It wants weekly hours worked, and it doesn't say, let me see if there's a thing about decimals. Oh, formatting, here we go. Significant digits should be like this, or average age of years versus this. They should be fine if you put 1 or 2 decimals. So they should be fine with 1 or 2 decimals. Since we're doing hours worked, I'm guessing, so this is GPA. 1 or 2 decimals should be fine. Please tell me if they take off for 2 decimals. I think that'd be ridiculous. 2 decimals is, in my opinion, generally a good amount to take things out to. I mean, I'm fine with that. 1 or 2. So let's go here to home, and you need to click this button right here. I'm clicking the decimal reduce right there, or does it say decrease decimal? And we're just going to decrease the decimals down to 2 decimals. This is increased decimals. This is decreased decimals. If you do it at this step, it's a lot easier than selecting the whole table, but this will change the decimal formatting for anything that is in aggregate of this, anything that comes out of this. So now we're going to put in, I think, 2 categorical variables. Let me look at the instructions. So now it wants us to use gender and having a student loan and look at the differences. Okay, so we're not doing that one right here. We're doing one similar to it. We're going to choose 2 categorical variables. So we're going to choose whether people born in Tennessee, and make sure to put these in the right spots for yours, wherever yours need to go. Make sure they're in the right spots. And we're going to see, let's go family order. This is going to be quite an interesting one. So if you look right here, I've put in my variable here, born in Tennessee, and family order. What you'll notice right here is the table is showing like the middle child, which I am, who was not born in Tennessee, had on average a 3.79 GPA. If you see right there counts, make sure you change the value ordering. So the value field setting changes how that variable is being displayed. It by default is the count of the individuals, and we want right here to have the average. So remember, change this to the average. Does it matter which one goes in? That's a really great question. The answer is, let me double check, because I don't want people to get it wrong. Okay, it says right here, I think for the next one it might. Let's see here, display on average. No, I don't think it matters. I don't think it does. I don't see it saying for the columns and the rows it's going to matter. So good question right there. I don't think it matters at all. Yeah, tell me if they take out points. They shouldn't, because I don't see an ordering for that. For the next one, it looks to be a bit more specific. So now that we have this, we're basically there. I'll show you all the tricks. You ready? Because now we're going to go to insert. It's not recommended chart. Was that going to do it? No. There we go. I so many instructions to remember that sometimes my brain just says, wait a minute, where do we click? So you need to go to pivot table analyze, pivot chart, and it's going to give us kind of the default pivot chart. Now we could teach like a whole month on pivot charts. There's so many different types to use. Knowing which one to use and when is very important. But I've helped multiple people make pivot charts for different things because there's really great techniques you can use. It's probably telling me my data is not the right type of data, but that looks so cool, that surface area. I mean, we're not going to use it because I don't think we have the right data for it. But there's so many options. Okay, don't do what I just did. Don't click around. You generally don't want to make things 3D, but there's so many options. We're just going to go, it's bad. You don't want to do stuff like that. You're not supposed to do stuff like that. That's what they teach us. Okay, let me show you again how to get here. You want to go to pivot table analyze right here, and you should see pivot chart right here. So go to pivot table analyze and go to pivot chart. Does that work for you, Sarah? So you just make sure you're clicked inside the table somewhere. So make sure you have the decimal formatting correct. I might do one other thing right here. For mine, I'm going to move oldest to the top, and I'm going to put only child to the middle. If you click right on one, and then you go to this little bar right here, it's hard to see. It's right there. You can actually move them around. So that's one way to move them around. Oh, no. It's really hard to see. Even I was like, where's that again? I ordered them. You don't have to do that. Mine just has a logical oldest, middle, youngest, and only child. Only child is kind of a unique. It doesn't go in the ordinal data set. So let's go here to pivot chart, and we're just going to click OK because we have what we want, and we get a pivot chart. Okay. Now you can go through and add in tons of options. There's so many options you can add in, and you can do them individually. So this is a great way to just go through and be like, I'm going to add a chart title. I'm going to add axis titles. And I think we have everything we need. We can just probably click data table. Yeah, I guess that's got it. There's another way. The other way, which be careful. One thing you can do now is you could go to, where's my quick format? Here we go. There's under quick layout, this one has everything you need but one option. So if you go to the quick layout, this has everything but one axis title. It's missing the primary horizontal. So just make sure yours looks like this. Let's do a checklist. Here's the checklist of what you should have. You should have a chart title. You should have axis title, and a data table or data labels on top. You don't need both. You don't need also the data labels on top. It's just redundant information. But you could have one that looks like this. This is perfectly fine right here, unless it says you must have a data table. It's probably down here is where it says display data table elements below the chart. So it does say data table. We should accept, you see here it is, your title prepared with your name here. So let's copy that. Descriptive access titles display the data table significant digits. So we literally have a checklist of things we must do for this. We need chart title, axis titles, data table, not data labels, data table like I did, and don't do the data labels, and then the significant digits. And let's do a checklist here. We do not have data table. We need the data table down there. So let's remove the data labels. So here's our data table. Here's our chart title. Here's the axis titles, and here's the significant digits corrected. So with this, we now have a good-looking pivot chart that we need to just fill in with the information. It's pretty interesting. If you notice this kind of flow downward of it, also notice that the people born in Tennessee, ooh, look at that. That's really interesting. What do you notice about the people born in Tennessee versus their counterpart? The people born in Tennessee versus their counterpart, what is there to notice with that? I've only got a tiny bit of coffee left. I find that pretty interesting that the person born in Tennessee versus their counterpart, I should have been born in Tennessee. I was born in New York. The person born in Tennessee, this will be the things you want to mention. Like in your write-up, you'll want to mention that the person who was born in Tennessee generally had a GPA that was a little bit higher. While the differences were small, 0.03 for oldest child, the differences could be, yeah, exactly, Lucy, great job. The differences for only child were the biggest. So notice how we're going to mention some numbers here. In my write-up, I'll say the person who was born in Tennessee always had a higher GPA than the person who was not born in Tennessee. The differences were smallest, where oldest child had a difference of 0.03, and the only child had a larger difference of 0.14 between not born in Tennessee and born in Tennessee. Basically, describe these numbers in words. And I'll do more of the write-up here in a second. So let's see here. Average high school GPA by born in TN and family order. I'm going to hit enter. Prepared by Brian Stevens. Okay, so now we just go here to this axis. In this axis, it's going to be family order. And in this axis, it's going to be average. Make sure to put average here. It is average. So it's not someone's high school GPA. It's an average for individuals. And we've now done it. You can kind of make it look nice. And there's two ways to bring this. Good to see you, Kayla. There's two ways to bring this into your document. There's other things you can do. You can edit the colors if you want. Like, this is the born in Tennessee. So can I choose my color from... I want to choose like the exact color because I know the Tennessee color. More fill colors. Really? You won't let me put in the chroma key color? That's close enough to Tennessee orange. What should this be? What color should this be? We'll make it a big contrasting color, darker blue. So you can do whatever you want right there. Good to see you, Leslie. But anything you want here is just optional, like outline. I've never done an outline. Sure, let's do that. I'm just having fun right now. You don't have to do this. This is all extra accoutrements. And so now there's two ways to bring it into your Word document. One, you can copy paste it as kind of an object. So we're just taking it and copying, pasting it. It's still editable in the Word document. It should be, yeah, you can still make edits to it in here. Sometimes it changes the colors a little bit, but this is still an editable object. You know what? The more I look at this, the more I'm like, why not copy paste it this way? One reason I don't like to copy paste it that way is because you could make a change and not know it, but you can still go in here and edit titles and stuff like this, which is nice. But the other way of taking an image of it is take a screenshot, which is all right to do. Just make sure you don't get extra things. You will lose points if you, like this screenshot right here, that would lose points. And this screenshot right here is a good screenshot though. We're taking just you probably don't need that family order on the bottom. You know what? We don't need that high school GPA at the top. That would not lose you points. I think the graders would be too strict if they remove points for that. But truthfully, I think that's a great screenshot. Now, why would you do this way? It's now static. The image is not going to change. This is an image you can't kind of like make changes to, which is a good thing if you are afraid that you'll go in here and accidentally hit a key and make changes to it. So it's all, your preference, whether you want to copy paste the image or the screenshot. Either of these are quite acceptable. Make sure you notice that these look nice and neat on the page. On the x-axis, Tyler, do you want us to put in column or row? You don't have to put in column or row. Just like, does this make sense right here, Sarah? Like, this is an excellent screenshot. Like, this is the way, I'll reappear. This is the way the screenshot should look right here. Sorry, I'm fixing my stuff. Oh, it's Puppet Shark. Sorry, I forgot about you, Puppet Shark. He's over here next to me, and I'm like, what is next to me in this? We're going to talk through this here in a second. There we go. I just wanted to move myself to the side more. So let's talk through this. What do we see with this graphic? So you put family order on the bottom axis. Do we put loans or gender? I think either's fine. I'm 99% certain. Let's double check the instructions. No, that's fine. That's fine. This is, it's pretty chill right now. So we're just ask all the questions. I mean, ask it when it's going crazy too, but ask all the questions. So on these and the rows and one category, yeah. So this is going to be categorical also. So this is I basically did pivot chart too. I mean, technically someone can do the one that I just did for pivot. Let me just say that. So I can do pivot chart too, but what I just did right now, you can literally use what I did for pivot chart 2. Does that make sense, Sarah? Because it wants you to take one categorical variable for the columns, one categorical variable for the rows, and a quantitative values, and then you'll display the average. And that's it, but not all columns may need data filtering. So we don't have to filter our data. So yeah, I just did this one. And then right here for this one, you don't have to, it doesn't matter which goes in which spot. It's not very descriptive on if you want one in columns or rows. But you can flip them pretty easily. if you go to, like, let's say you don't like how this looks, we click inside of here. There we go. And if you lose this, a lot of people might lose it by accident. You just go to the field list. So if you can't find your field list, go to Pivot Chart Analyze and go to Field Lists. That's how that appears. And if you take and flip these, it'll make a very different looking chart. You see, I don't like that one right there. That's too wide. It's got too many categories. I don't like the way this looks. If I were to, I don't know. Someone might like the way that looks. You can see better the relationship that the oldest has the highest GPA here. Like this one makes it easier to see oldest has the highest GPA, and then we see differences, and that's pretty interesting. But you can also see right here that relationship that oldest has the highest GPA over here. So maybe flipping it will give you some quick analysis of how to read the chart and understand what's going on. I prefer one that looks like this. It just depends, and then just get it the way you want it to look. And then only, I want to make this clear, sometimes people do everything I do. I think people know, like, don't do everything I do. You don't need to put this in here twice. Does that make sense? Someone, I know Sarah, Leslie, Kayla, anybody, just make sure people know you don't need to put this in here twice. I'm just showing the difference between here's a screenshot where I took it as a screenshot, and here's where I copied it as a graphic, and I can still do the editing to the graphic itself. You don't need to put it in here twice. Like, don't, let me just be like this. Don't put the graphic in here twice. Don't do that. Thank you, Leslie. I'm just, sometimes I do something in a video and I think people watch these videos on mute. And so then they just do everything I do. They're like, oh, he's copying it twice. I don't know why we need to do that, but I'm just going to do that. So I'll see some visualization assignments where I'm like, don't do that. What are the activities assignments for BAS 320? Also, I have a few R questions. Yeah, okay, let's do that next year. The activity assignments are basically attendance-based. I think we'll do one today. So I think I've only done one in one class so far. Basically, I just take attendance, and then we just work through some R stuff. So as long as you're in class at that time, like, I don't think you would do this. I'm not saying like I think someone else would, but don't fill out the attendance form if you're not in class. Like you could technically be like, hey, did we have an attendance thing today? Okay, I'm going to put that was in class because, I can check like the YouTube chat, and someone could watch class and just not chat. But if there's reason for me to believe, I might double check with someone like, hi, I've seen that you've been putting in the attendance and I haven't seen you in class. And can you just make sure to chat when you're in class or say hi or something so that I know? Yeah. So does that make sense, Kayla? I'm just so I can make sure anyone watching this knows that it's attendance based. Yeah. And then aside from me actually seeing who's physically in the room, like you think if you do an activity in class, you can be like, here's an attendance sheet, let's pass it around. So when I do it online, I have to be like, hey, here's the link, fill out the link. And then someone could, yeah, it's, you just don't do it. I don't think anyone would, I hope not. So let's explain this graphic and let's do some R. So with this right here, what do we have? We have average high school GPA born in Tennessee and family order. Make sure to mention 3 key aspects right here. Let's make sure people see. We have average, which is key. That's also on this. We have variable 1 by born in Tennessee. We also have the variable here, and we have family order. So if you notice, we're mentioning our variables, and then we also have the variables on the axis. Here's what I would write up for this, which you can basically take this for graphic too. I'm just dropping mad hints today. So we have here that in this graphic, we're displaying someone's average high school GPA by the variables born in Tennessee and family order. The oldest children have the highest high school GPA with 3.83 and 3.86 for those not born in Tennessee and born in Tennessee respective. The individuals with the lowest GPA were the only children with a 3.60 and 3.74 for not born in Tennessee and born in Tennessee respectively. And you can clean up the wording if just make sure to be mentioning the numbers here. Now I'm going to mention some trends in the data right here. So the trends I'm going to mention are, so I mentioned the highest and lowest. That's a good thing to do. There's a trend in the data that suggests that the oldest child have higher GPAs than their middle, youngest, and only child counterparts. Generally, we see about the decline is small going down from oldest to youngest, a difference of about difference about a point. I might even cite these numbers, 3.83 to 3.76, 3.86 to 3.79. But there is a large gap where the only children have a much lower GPA than other individuals, 3.60 and 3.74 respectively. We do see that people born in Tennessee have a slightly higher GPA in all groups. For example, oldest children has the smallest difference, 3.83 to 3.86 for born in Tennessee having a higher GPA. Do you see I'm just like going through and kind of mentioning things like almost like you wouldn't have to see this graphic. So that's the key right there. Is you want to walk someone through and mention each group, and not like you don't go through and be like, this group is this group is this group is this group is this. You want to talk about the trends. You want to say like there's a trend in the data right here showing that younger children generally have a little bit lower of GPAs, and also we see a trend that the people born in Tennessee have a slightly higher GPA. And then mention the numbers. I can't, let me just put that right here. Like mention highest and lowest, mention trends. Always be citing the numbers. Always be talking about those numbers. Does this make sense, Sarah? Any other big questions? Because second graphic, which I basically did for this one, if you've done this, and you should be good. Did you get it done, Sarah? And then we're gonna hop over here, Kayla. Let's do some R. Kayla's wondering if we could. Let me see Kayla's question again. How did I lose it? Yeah, let's do R questions. What questions are you wondering about in R, Kayla? Let me pull up R right here. What were you wondering? We did 100 lines of code almost. We did 100 lines of code yesterday. I love that. Here was BAS 320 yesterday. You're welcome, Sarah. Sarah, keep it up. Join in any of these office hours. Keep getting the work done. Keep working ahead. I mean, nothing like being like, I'm a week or two ahead in a class and being like, I've got an A in the class. I'm a week or two ahead. And, you know, Marty, like, I know most of the test material because I'd say, yeah, if you understand what we've done so far, what is the tail function? Our logic operators like union and intersection in math. Yeah. So let's take a look at those. So the tail function, for some reason, that's my computer audio. Yeah, we're good on everything. Okay. Cool. Now I can see it better. Half of the reason I make these things bigger is so that I can see it. It's not so you can see it, so I can see. Okay. So let's talk about the tail function right here. And to know tail, we also need to know head. And I think that'll be good. Okay. So let's go ahead and make a vector right here. This vector is going to go 1 through 100. So we're going to exit out of our graphics so we hopefully don't get that error again. Let me go here, clean out all the graphics, and that should fix any graphical error we're getting. Okay. Oops. Really? Oh, did I not type? Oh, I don't think I had the right thing in anyways. Okay, there we go. What did I want to see what command I sent. Yeah, I didn't save into. I was like, what did I do? Okay, so we are saving 1 through 100 into the vector right here. So what does this do right here, Kayla? What have I created in the brain of R? Like we know the left arrow is save into. We should know that instantaneously. And then I have a vector 1 through 100 right here. So we should be able to read this. Vector 1 through 100, it's just a sequence of numbers, is saved into, this is the save into arrow, the object vector. Exactly. That, and so just the more we read it as a sentence, the better we get. So tail is a function that talks about the end of something. You can do it for data frames. Tail works on multiple different objects. So when you put something inside of tail, it's going to return the end of it. I mean, just think about an animal. Like if you have a dog, so dogs have a head and a tail. So the reason it's called tail, and is it showing us about? Oh, it's showing us vector right now. The reason it's called tail, there we go. The reason it's called tail is it's going to show the end of a sequence or the end of something. So what will this do? It'll return the end of that vector. By default, it returns 6. And you can see this if you look at the tail documentation. Does it show us the default 6 right here? It doesn't. You have to go and look at the documentation, which I'll disappear for that. So if you look at the documentation on tail, both head and tail by default show 6 by default. And here it is right here, the n, and this is integer value right here. Don't worry, that has an L on it. It's just integer 6. You can just put 6 here anyways. But what happens if I go and think about this while we look at the documentation? If I do this right here, if I do this, what will this return, Kayla? So look at the sequence and think about, yeah, exactly, yep. And you don't need to put n because it knows that by default because the second argument is n, so you don't have to put n. It knows that by default. It'll assume you're assigning the value to n, by default. Is this making sense, Kayla? Really great questions. And this is what I want people to do. I want people to like do some stuff and then ask questions and be like, well, what does that do? So what does head do? What does it do? If we go over here and we do the same sort of code, what does that do? So think about like a dog with like head and tail. So where tail returns the last, exactly. It's exactly right. And we could try this out on a data frame. You'll see. So yeah, these are the great questions. Keep it up because we can take a data frame right here. If we go to the head of a data frame, I think it'll return the first so many rows. So if you want to just take a quick look at a data frame, you can do this right here and it returned the first 6 rows. So this data frame is actually rather large. So we're going to do this. We're going to go to head of iris. So this returned, make it smaller so we can see everything. There. So if you notice what it returned right here, it returned the first 6 rows of the iris data frame. So if you run head on a data frame, you get the first 6 rows. If you run tail, you get the last 6 rows of a data frame. So maybe you want to see the end of a data frame. And you're like, let me look at the last 6 rows. Or you could, look at the last 3 rows if you want. So here's the last 3 rows.
Narrator dialog.
Oh my gosh.
Oh, narrator heading level 1. Exiting narrator.
That was crazy. I think I hit Control Windows Enter like all at once. I did that. Does this make sense right here, Kayla? Like keep asking questions. I think you had another one too. And they have about our logical operators like union and intersection in mathematics. That is, so when we use like union and intersection, so the union of two things, and so let me get this right. I'm gonna like make a mistake because if we go to mathematics, that's where I get worried. And let me double check like what you're talking about the coding here. You're talking about Kayla, you're talking about these, right? Because what we should have right here, let me make sure I use the correct, because I bet the DataCamp is calling them either or both union. Yep. So like I did the DataCamp intermediate R, like when did I do it? I did it like 3 years ago. I use, and then like they have specific ways they refer to stuff. And definitely it helped me with my wording going through it. So when you look at the union of two things, let me make sure the intersection, let me like draw it out mathematically here. So as soon as we start talking things mathematically, my brain starts to break. I'm a stats guy. So we have two different things right here. So in mathematics, this is the probability of A, and this is the probability of A and B. So this is going to be unions. This is that a union right there? I have to think mathematically for a second. Intersection, that's an intersection. That's the intersection. And then and so the union, so probability of, well then probability of A or B is going to be, it's going to be everything like on these. So probability of A or B would not, because we just need to be in one of those. So probability of A or B would encompass everything right there. If it's just A or B. If there's other things outside of there. So visually, it should look like this. Like, what's the probability of A or B? And this says that. So the, yeah, because the U is like. See, I just always remember. Here's the way I memorized it when I had to go through mathematics. Is this is like, this is A and B, and this is like the or right here. It looks more like a, I don't know. The and I always remember the N of the and. So this is how I memorized it, and I still had it in my head and. That looks most like that. Like if you were to imagine this right here, I mean, it's, I don't know. This one looks like that. And the logical symbols are equivalent to union and intersection. Is that how they describe them? I might double check. Like I was helping people out with intermediate R. I didn't do this part again lately. So when we do this, 1 hour till teaching to one. When you think about the ands and the ors, probably the quickest way to memorize what an and and an or does is in a sequence of logicals. If you have ors, so understanding, let's put understanding. So when you have a sequence of logicals, with or, you just need one true. So if you have a bunch of things like here, this is going to tell us true because there is one true. So or will return true as long as there's one true. So using intersection and union, I'm not that good with that terminology. And it's because I talk about things a lot in the business analytics sense. And if I were to explain to someone what this does, like business analyticsly, I would say, we will achieve our goal as long as one goal is achieved. Like if we meet it in one area, we will succeed. Like let's say we're looking to see if we met any of these goals. In this instance, we will achieve our goal with all these ors if one of the goals is achieved. Does that make sense, Kayla? So end only returns true if all. That's exactly what you know. That's exactly the key thing you should know. So with and, you will not get a true right here. So let's change these to trues. So I mean ors. Oh my gosh, ands. Suppose when you make an example while you're talking through it. Okay, my brain knew what I wanted to do. So this will return false because there's at least one false. Everything has to be true. Everything has to be true for it to return a true. So we'll have to change all of these to true. We can make it a shorter sequence, but now it will return true because everything is true. So understanding that when you have ors, you just need one true to make the sequence of ors true. If you have ands, then everything needs to be true in a sequence of ands. So one false will destroy a sequence of ands. One true will make a sequence of ors true. Yeah, this is equivalent to the math terms then. Awesome. Oh wait, Kayla, are you the mathematics major? Like, do you want to explain in better detail? Are my diagrams correct? Yeah, you are, right? Kayla, like no one else is talking right now, so let's go a little bit more mathy on this. Am I drawing these out correctly? Like, help me with my knowledge a little bit here. Like, did DataCamp refer to them this way, or just with your mathematics major, this is how you think of them? They are correct. Okay, good. Yeah, and sometimes the terminology I just can't remember the right term, and I should know since I teach. I should hopefully know all the terms. So the top one, this is the union, right? And I'm making connections. Math always my first thought. Yeah, exactly right. I guess this is union, and that's intersection. And I always think about the or right here, like, yeah. As long as you're in one of those areas, because you think about this is the area outside right here is like both are false. But this would be A is true and B is false. This would be a true false right here. This would be a true true. And this would be a false false. I mean, no, what am I saying? False true. So if you think about this, like in terms of are you inside of this area, true false, true true, and we should put those in green. So let's put this. This is a good way to describe it. So it's false, false for that one. And now we need the green marker. So the green marker here. So this is true, false, true, true, and false, true. So, and then the only way to be in this one is with true, true. And up here, this would be true, false, false, true. Let's add our false marker. So the only way to meet that, I think, makes more sense of it. Does that help right here, seeing it, Kayla? That in the or, you can be an A, B, or AB as long as there's one true. But with the and, because now I think this makes perfect sense. With the and statement, you have to be in the both being true. And if there's like three, you have to be in all three. Like you have to have all true for everything. You can't have true, true, false for the ands. You have to be in the union of all of them. And you can make it confusing with like trues with ands and ors and joining stuff. It can get very complicated very quickly. But hopefully this graphic right here kind of exemplifies the differences. I think once I edit in the trues and falses and bring it back to how we're doing it in R, hopefully this makes a lot of sense. What other questions do you have? What should we talk about? Graphical displays really help me. So I'm always trying to like show what I see in my head. Like, it's like, okay. Here's how the and works. You have to have two trues. You can't be in like a true false, like are you in A or B? We have to be in an easy way and all true, or at least one is true. Exactly. Yeah, exactly. N equals all true. Yep. And that's what we should, so let's put it right here. Let's put a note on that. I have the white marker. So let's go right here. Oh, I need to bring a space pen. So let's go right here. All true. At least one true. That's got it. There's our notes. Let's bring a space pen. We've gone all semester without space pen. And it's usually space pen versus rainbow pen. Space pen. Rainbow pen. There we go. Now we have rainbow pen. Rainbow pen is back. Or not. What? There we go. What questions are there? We could do a little bit more coding here, getting to the end of office hours, but feel free to ask questions if you have them. I think a really confusing one for people, Kayla, is the %in%. That's where I usually see people get lost. You're in today's class, right, Kayla? Because we covered a lot of this yesterday, or you could be reviewing from yesterday. The %in% is one where people usually get lost. Yep, no, so don't worry. This is a really good head start. So whenever you see %in%, it is read is 2 contained in 2. And just think of, it's going to check this side right here to see if this is over here. So what do you think this will return when I run this code? What will this code right here return? If I ask it, is 2 contained in 2? Just think, like, the best thing is like, yep, true. What will this return right here? Is 2 contained in the sequence 2, 3, 4, 5, 6? Which you can view it this way, but this is the same code as this. There's the same sequence. This will also return true. But then, oh, what did I do? Oh my gosh. Click $signs instead of. There we go. And so now, what will this do? This is logical equals. So is 2 logically equal to, and I guess we could start at the very beginning with the first one we did, is 2 logically equal to 2? And so, well, this one's going to be a little bit different now. This one works a little bit different. This one says, is 2 logically equal to, and we're going to take this, because this will make it easier to see. Is 2 logically equal to 2? Is 2 logically equal to 3? Is 2 logically equal to 4? Is 2 logically equal to 5? Is 2 logically equal to 6? So it's going to go through the whole sequence right here and do each kind of check on is 2 equal to each one of these. So it'll go through the whole thing. So it'll return true, false, 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 however the length of the sequence. Does that make sense right there? It's going to check the logical equivalence and go through that. So if you notice right here, on %in%, returns length of left side. And this down here returns the length of right side. And what do we mean by length? We mean if there's 5 elements here, you get a 5-element return. If there's 1 element on the left, you get a 1-element return. So how about if we do the following? What will this return? Only focus on that one right there for the moment. What will line 22 return? I'll put the hints next to them. Let's see. Do you know what line 22 will return? It will return length of the left side, though. Make sure the length of what the return you guess is the length of the left side. So whatever whatever return we have will be the length, like whatever will have this many elements. So what is the return? It will return true, but it will return true, true, because there's 2 elements. So it'll check, is 1 contained over here? And it'll say true. Is 2 contained over here? And it'll say true. Does that make sense, Kayla? It'll return true, true, because it checks the length. It returns the length of the left side. So it's going to say, is 1 contained over here? Is 2 contained over here? Thank you, Mubot. Mubot's always helping out. And so what will this one return? What will this one return? What will line 23 return? It's just practice. The more you, exactly, it's gonna go through and say, is 1 contained over here? And then it's gonna check is 2 contained over here. Correct. This one will return true, true, false, 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 false. But now take a look at this. So I think with ordered pairs, I think you might be referring to how this works. It's like ordered and in pairs. I know ordered pairs. I got to remember the mathematics terms. You're like, no, Brian, that's not what I mean by that. Close. So the way this works is it goes through here and it says, is 1 equal to 1? Is 2 equal to 3? When it checks 2 right here, what's it going to check to see if 2 is equal to? When it checks 2, what's it going to check to see if 2 is equal to? When it checks 2, what's it going to check to see if 2 is equal to? There might be, I'm trying to think of a way to make it. Yep, exactly. It's going to check if 2 is equal to 1 because it's going to go 1 equal to 1, 2 equal to 3, 1 equal to 2, 2 equal to 4, 1 equal to 5, 2 equal to 6. So it's going to return a false for this 2 right here because it was checking to see if 2 is equal to 1. And we can confirm this by putting a 1 right here. And if you put a 1, it'll change this element to true right here because that's what it's checking. It was checking this element against 1, and you could confirm that this one is checked against 2 right here because when you put a 2, that becomes true. When you put a 1, that becomes false. You know what would be interesting is I want to make it so it returns. I wonder if it doesn't like that. Yeah. Oh, I know how to do it. Okay. What you want to do is this. Is this equal to this? Or is this equal to this? There you go. So now we're seeing anywhere. So we could put a 2 in here, like where it had errors before. But now we are getting basically. Does that make sense right here, Kayla? Now I've done where if a 1 or 2 is in the sequence. So 1, 2, 3, 4 equals this would be because let me double check. It looks like, and then we saw some C's before that. So let me tell. I think you got it. I think there's gonna be one issue with this, though, and I'll explain. Okay, so this right here is gonna have a false at the end of it. Correct. You are correct, and it's also gonna give a warning message. Great job, Kayla. You are exactly correct that when it starts back over here, it's going to check 1, and we could confirm this by putting a 1 right here. It's also going to give a warning message saying that the lengths are different of the vectors. So there's the warning message, but we do get the true at the end because we did put the 1, and then we could change it back to what you said, and excellent job. And the warning message is just like, hey, you have different length vectors. You can do something though. You can go suppress warnings. I don't want to see those warnings. So if you know you don't want to see a warning in your output, you could suppress the warnings. Does that make sense? What suppress warnings did is I took the code, I wrapped it in a suppress warnings, and then the warnings don't appear. Are you with me on that, Kayla? Because I kind of did that quickly. I just took code that put out a warning, and I said, hey, don't give me that warning anymore. I don't like seeing warnings. So before, yep, awesome job, Kayla. Yep, and you're 100% right that when it goes 1, 2, 3, 4, 5, and it has an extra element right here, it loops back to this side because it returns the length to the right. So you're doing this is you're way ahead of the game here. You're understanding these things at the level I want you to understand it, and you're making your own code, which is the key. If you can figure out what code does, then you know how to code. You're like, oh, I want it to do this. It's what's really cool is like I'm gonna show the HackerMan logo again, as this kind of goes into learning. I used this HackerMan thing, like the glow thing going across of it. I made like actually had to animate that, and it really like. This was like a combination of all the skills I've been learning from different things to make the logo. So there was no like step by step to make a logo and then make it move sideways and stuff and to make it have the glow across the top of it. So I've done multiple tutorials, but then I decided to make something that no one had made a tutorial for, like how to make your own hacker. I used the Photoshop thing I used a tutorial for, but then doing the effect. So I can't tell I'm really proud of it. I spent a good bit of the weekend making it. It takes a moment to load in right here. There we go. So what I did is this glow thing over the top of it is actually from a Smash Bros intro. They showed how to do like the lens flare effect. So you start to put things, knowledge you have together into different things. And also the 3D effect was from making the Smash Bros intro, which I haven't used that other than for a visualization thing. But I did a whole tutorial on, visualization and use the Smash Bros intro. But the knowledge I gained from that, I was able to convert to like, okay, let me take the lens flare effect and do all these different things. And there's more effects down here, but this is the deal with coding: is you take bits of knowledge and then you go through and use it and figure out how to do other things with it than what you are being told to do. So I don't know. I think the more you can take, like you just did right here, Kayla, is you made up your own example and you're like, oh, so if I do this, it'll do this. Then when you need to utilize it in something else, you'll be like, oh, wait a minute. I need to do the thing where I check the vectors. And okay, if I do the length here, then it's just like with, this, I'm like, okay, I want to do the thing where I have the lens flare and it goes across the top of it. And yeah, it's just, you have to start to put it into your mind where you can use it outside of how you're taught to use it. And that's the hard part, because you have to like, what do I need? No one's telling me what to do at this point. Well, great job, Kayla. More questions anyone has? I don't know. It's weird. Like, I'll sit down. This is almost like a video game to me. Like, it's like beating a video game if I make this work. So, what's funny is I got this done in like an hour, and then exporting it took like another 2 hours. Would you care to go back to line? Of course. Line 25 right here. So what is line 25 doing? So line 25 right here is, just look at the two sequences, and we don't actually need this concatenate or combined. I finally learned it's called combined. Where did I learn it was concatenate from? This is the same code right here. And so what does this return? Let's just break it down into two sequences. With the two sequences, this sequence right here is going to return what? So think of it as two sequences right now. What is this sequence going to return right here? It's going to return true, false, false, true, false, false. So, yeah, but I think there's one true right here, the fourth element. So true, false, false, true, false, false. And then this one right here will return, false, false, true, false, false, false. Does that make sense for the next one? Because I think you're doing the first one still. And then this one will return false, false, true. So now when we put these together, if you go element by element through this, can you see where don't tell me, wait, I got this, ready? The union, can you see where the union is of these? I'm just gonna make it so only this output appears. Do you see the union of these two vectors? Like here's this one, here's this one, here's this one. Tell me if I'm using the term correctly. So the union of these two vectors would be what? What would be the union of these two vectors? What is the union of these two logical vectors? Solid. So remember, so not the whole thing. You're going to go element by element, like this one, 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 this one. What will be the union of these two vectors, like pairwise union? So like the union of this, 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 union. Does that make sense? It's gonna, yeah, that's it. So now it's this whole code is the union of these two vectors. Does that make sense? As we go through here, it's gonna check the union of both of these. This is, if you could have produced this right here on your own and known the output, you super understand logical operators. Like this is level like 8 or 9 knowledge. I mean, you could go beyond this and do even crazier things, but this is a really big combination of, but just break it down into parts, be like, I'm checking, the union of two vectors, and it's going to go pairwise ORs on them. So I wouldn't expect someone in 320 to be able to produce that so quickly. But does that make more sense as we break it down, Kayla, right there? That we have here these checks. And so here's the check, is it equal to 1? Checks pairwise each of these. Yeah, no, great job, Kayla. That is the top level example. And if you understand it, and if you could reproduce it, you're high level. But if you understand it, you're doing well beyond what I would expect right now. Awesome work, Kayla. What do you think so far? How's everything going? What math are you taking? I should ask. Like, I think you already mentioned you're taking. I know you said you've taken real analysis, so you've gone far past the mathematics I know. And always feel free to give mathematical lingo and to add to our knowledge. You only help me and other students by explaining things that go beyond what we're learning. Numeric analysis and problem stats, math version, yeah. Let me say this. My friend Emil Williamson, who has his PhD in business analytics, he knows mathematics. If you are a PhD in business analytics, you're expected to know real analysis. You're expected to know, partial differential equations. Like I think I've done one PDE in my life. I've done ODEs. Everyone, non-math people are like, what are you talking about PDEs and ODEs? I mean, the Hessian, all this stuff, you know, gosh, second partial derivatives and stuff like that are just, Dr. Bosdogan in our department, let's talk about Dr. Bosdogan for a second right here. He's got a lot of awards. He is, Dr. Bosdogan, he is really knowledgeable, and was that his? It's got like a different profile. It's got a number. I don't even know that number. Let's go to this. Cool. This is this profile right here. He is super knowledgeable. Dr. Bosdogan, Humphreys Bosdogan, really, 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 really smart guy. I mean, look, there you go. And you know what? I didn't know this. I should have known this. His PhDs are in mathematics. So, yeah, I took courses under him, and he studied under Dr. Hirotoga Akaike. And so he was in Japan for part of those times. But his about him section is pretty big. Yeah. So really honored because if you go to classical stats, you're going to see a lot of people because he's not business analytics. I mean, he does business analytics stuff, but he's classically trained in like mathematics and statistical analysis. Like, he's the one I took a very high level statistics course under. And yeah, it was tough. That was a tough course. He knows his stuff. Like, Scary knows his stuff. I didn't know his PhD was in mathematics. He'd try to say, yeah, bro, I have my PhD. Yeah. Oh yeah, because he was, and this is my last comment on this, because I love talking about math. I used to be good at math. I used to be really good at math, but you don't use it, you lose it. I'm talking about like high school good. College good's a different level. But Dr. Bosdogan was telling me that calculus is way easier to do if you do it with linear algebra, or like, do you know anything about that, Kayla? He was like, yeah, don't do derivatives with, don't do it with calculus. Do it all with linear algebra. You know, you can do all of, this with linear algebra. And he gave me a book on it, I think, and I think I have him back in parents' house in Kingsport. I didn't take every single book I have here, but he knows his stuff. Really, really, really nice guy too. Like, but yeah, I'll end on that. Let's put on a little music right here. Let's put on some more classic music. I just like talking about mathematics, and a lot of people have helped me in my life. I'm gonna put on this one. Kind of like some Western music, sounds like. But with that, it's the end of office hours. We did some 201, did some 320, found about Dr. Humphreys Bosdogan. And we will be back. But as we always say, bye for now, everyone. Bye.